All right, so let's see what we got for slides today. So as every day, I want to start with the clicker questions to check the pre-class reading. Then I have a hopefully short lecture, and then we want to put to work on how to actually do this class discovery. All right, so let's see what Piazza has for us. Nothing yet, because I have to make these questions. All right, so and I don't know why there's a G on every slide. We'll work on it later. Oh. Oh, wow. Yeah, so feel free to chat with your neighbor. I heard someone already starting that, and so that's perfectly good with me. So go ahead and answer this clicker question 1. So that I will just check it on my phone again like last time. Okay, so far all I have is 6 votes. Hopefully you can do better than that. I'll just make a new poll.
Are you asking if it's an object in the context of Java or in the context of like?
Of object-oriented design, so independent of the programming language. Right, the chapter doesn't say anything about Java. It just talks about what objects are. You need to look at the slides for the questions. The slide is whether the value 42 is an object. All right, so now I've cloned these polls. Okay, now we get 21 votes. Okay, but there's 28 people in the class, so let's do a little better than that. Yeah, so in the future it would be really nice if you could just, the first thing you do in class, you just fire up Piazza, because we always do that. All right, so now we have a bunch of votes. And so most people chose the option 3, and a few people chose option 4. So let's see what those options are. And I'm going to acknowledge that a smattering of people did the other. So, is the value 42 an object? Okay, and a lot of people said, no, it has no behavior. Is that what a lot of people said?
Yeah.
And I would disagree with that. It has a behavior. It can do all sorts of things. It can multiply itself with 3. It can add itself to 4. It can, stuff like that. So it has behavior in a way that they're operations, they're arithmetic operations, and you could say, they are done by this object. Some people said, no, it has no identity. And that is really where we're getting to the point, what is the implementation of it? So in Java, that is in fact true. It has no identity because you could have any number of different 42s, and you don't know are they the exact identical 42 or not. If you have a java.lang.integer of 42, one of those wrapper objects, that has an identity. You know where it is. It's somewhere in memory. And it's different from other 42s. But the number 42 itself in the Java implementation doesn't. But there are other programming languages that don't take that approach and where a number could be an object. So this one here has no great answer because the concept of identity somewhat depends on the programming language. 42 clearly has a state, a bunch of bits that make up 42. It has behavior. There are operations on it, like the arithmetic operations. And does it have identity or not? That really does depend on, particularly in Java, where they have kind of taken the identity away from the primitive type objects to make them easy to implement. But it's not a trivial question, and it shows that this definition of what exactly is an object is not as crisp as maybe we necessarily want it to be. All right, let's move on to the next question. So let's assume that we want to design a quizzing system so that people can take these clicker questions that I'm doing here right now. I don't want to use Piazza. I want to have a system that does them. So we want to design such a system. And what's that?
Is that an assignment?
No. Just consider it. And so, but what would make a good class when you start with that process? The textbook goes through this sections where they talk about how do you find classes, what makes a good class, what doesn't make a good class. So when you apply that, what you've read, to this question, tell me which of these things would not make a good class. And if there's more than one that you feel would not make a good class, you're going to have to pick the one that you think is the most distasteful one to you. Okay, I have 19 votes. Well, someone said, what is the answer to question 1? So question 1, there is no one good answer. So depending on how you feel about it, you could say, I think 42 is an object.
In some languages, yes.
And in some languages, it is implemented as an object. Or you could say, well, because in Java it's kind of squishy, I'm going to say 4 is the correct answer. So 1 and 4 are both good answers. I don't think 2 is a good answer, because clearly it has state, and very few people thought 2 was a good answer. And I don't think 3 is a good answer, because you could always argue that all of the integers, they know how to do arithmetic operations. It's behavior. They know how to do stuff. All right, so let's see what we're doing. Over here. All right, so here the vast majority of people dislikes the 4th one, and some number of people dislike the 3rd one. So let's look at what those are. Okay, I'm on a roll here. So clearly, student seems like a great class in this context, right? We model students, no question there. Question, the same thing. No one thought that was a bad example. I would vote for 3 as by far and away the worst of them. Why?
Looks like an effective.
It's not even a noun. right? The rule number one is that you look for nouns in the problem description. Is evaluate responses a noun? No, right? So, and it sounds like more like a method. Exactly, it sounds like something that you do. Yes?
You could make a class that evaluates responses. But
You could make a response evaluator.
Yeah.
Yes, that might be a better class. So I'm all for a response evaluator. That could be useful. But evaluate responses, I think, is terrible. So that would be my choice for the most terrible one. Wrong answer, also doesn't sound like a great class. You could think maybe there's a class correct answer and a class wrong answer. But it seems to me like that variation between correct and wrong, I'm not sure that inheritance is the right way, or class differentiation is the right way to solve that. You're probably better off having a class answer where there is a property of an answer, whether it's the right answer or the wrong answer. It seems weird to model the rightness and the wrongness as an answer, but maybe someone has a reason to do that. So my candidate would definitely be evaluate responses as the worst of the lot, because suppose I have an object and I'm told it's an evaluate responses. What could an evaluate responses possibly be? Like I say, a response evaluator, that's a noun. It could have responsibility, namely to evaluate responses. But if it's a verb like that, it's unlikely to be a good class. Now you would think, does anyone ever come up with bad classes? And people do with distressing regularity. So it's worth going over. All right. So the next thing here is consider a responsibility. And the responsibility here is to remove a message from a mailbox and tell me which class should be responsible for it. Because it's a key belief in object-oriented design that for every responsibility there is one object that should be responsible for it. And all the other things that might need to be coming in there, that they get passed in as parameters. So for every responsibility there is a single throat to choke. There is one object that is in charge of carrying it out. Is that an object of which of these four classes? What do you think? Okay, 19 votes. Huh. Interestingly enough, all the earlier votes were good. All right. All right, so here the majority of proponents said answer A, or answer number one, and in fact, the first 19 votes were all for this one, and then a bunch of others trickled in. So let's see why. So mailbox seems like a good candidate, right? Because a mailbox it manages its messages, so it presumably has a way of removing a message from its internal storage. For a user, I don't see how that could possibly work, because what's a user? User is something that has a username and login and stuff. The users don't store their own messages, and so it would be difficult for them to be responsible for removing them. And in a message, it's always hard for an object to commit suicide, so it would be hard for it to do that. Now, the message queue, I would say that's a legitimate thing as well, right? The message queue contains messages. So it would be somewhere between the mailbox and the message queue, and then one would want to think about which of the two it is. All right. So in general, where I would like you to be at is that when we come into class, that you have done the pre-class reading and that you can give reasonable answers about these, like today. Alright, so, oh, that's not what I wanted. No, I wanted to, oh, here they are. I wanted these slides. So you read about the definition of what an object and what a class is. You've all had a couple semesters of using an object-oriented programming language like Java or C++, so I'm not going to go through that in any greater detail. But I want to talk about this really important subject of finding classes and their responsibilities, because that is very hard, actually. So when you're given a description of some software system that you're supposed to build, how do you know which classes to start? So far, it was always pretty easy, because probably the instructor said, implement a class mailbox with the following 7 methods, and then that's what you did. But how do you come up with that? And so the first rule of thumb is not a bad one, that says to get some candidates for classes, some of which later turn into classes, some of which don't, you look for nouns in the problem description and ask, do they have an interesting behavior? And so here in the user, in the phone thing here, you would maybe there's users, maybe there's messages. These are all good candidates for classes. And it talks about passcodes in the manual. And then with the passcode, you could ask yourself, is a passcode interesting, or should it store it as a string? And in which case, you don't need a class. But it gives you a starting point of that investigation. So a lot of times, there are nouns that describe things that should actually be attributes and not classes. And then, fine, then they don't turn into classes. The same thing with the user. I don't think that there was a class user in the implementation of the voicemail simulation. It just did not rise to the level of importance in that simulation to do that. On the other hand, if one has a more sophisticated system, then one may well want to store things like usernames, contact information, passwords, and so on with each user. Then a user starts acquiring interesting state. So when you look at classes, it's a good idea to start with high-level concept first, and don't yet worry about implementation. So when I say a message queue, then I don't necessarily mean a queue that's done as an array list with wraparound. I don't necessarily mean a linked list. I just mean it's something that stores messages in a first in, first out form. Now, the message queue is, of course, appropriate in the phone, because in a phone interface, all you can do is listen to them one by one. If you did this on as not a voice application, but as a GUI application on a phone, you would probably have a message list, because it's important that you can look at all of the application, all of the messages, because, of course, a user could tap on one of them in the middle and want to see it or want to erase it. So in that case, you wouldn't come up with a message queue in the first place. So we might even say a better abstraction would be a message store. We might say we have one store for the new messages, one store for the saved messages, and we later worry about how to organize them. So there is a categorization of classes in the book where that's just to give you some ideas of other things to look for. The tangible things, they're the kind of class types that you exhaust by looking at the problem description when it talks about messages and users and mailboxes and that kind of stuff. Those classes by themselves are not usually good enough to build an entire system, because you will also need classes that handle some of the internals. And so it's somewhat useful to think about other things that can happen. We'll soon see classes for events, where events are sent across the system. Something that contains a whole transaction could make a good class. An agent is someone that does something. What was the thing that we had a few minutes ago? In the quiz, the thing that wasn't a class. Mine's a sieve. Yours too. The evaluate answer, right? But an answer evaluator, that would be an agent. That would be someone who knows how to do a specific thing. And you might have different answer evaluators, one for multiple choice, one for fill in the blanks, for example. So those might be good classes. There's good agent classes. At some point, you will have a class that implements the whole system. Yes?
Is that agent or engine kind of the same, similar thing?
There's no standard terminology. I wouldn't. An engine generally is something more heavyweight. Like there is in Java, there's a script engine that can execute scripts in a different programming language. Whereas an agent tends to be more lighter weight and focused. But that's just convention. There's no real definition. So I will certainly never ask you, is this an agent or an engine? So the standard a standard agent is someone who can do something that's not terrifically complicated. So systems. So at one point you will have a class mail system or quiz system or some such thing. And it's always a bit of a dangerous thing. You need a class that kicks off the whole thing, that contains everything. But you also don't want that class to become all-powerful, because then your object-oriented program just has one or two classes and it's not all. You don't benefit from the distribution of labor in different classes. It's very common to have classes that are there as facades for external systems, something that interfaces with a database, for example, or with a web service, some such thing. And then you have foundational classes like dates and strings and that kind of stuff. When it comes to foundational classes, we'll soon document the classes that a program uses, and you never say, oh, I need dates and strings. That's just taken for granted that you have those things. So you would never in a diagram say some class depends on the date class or on the string class. Those are kind of just there as support services. So identifying classes turns out not to be all that difficult with a little bit of practice. The harder thing is to figure out what exactly should these classes do. And so the first rule of thumb is you look for verbs in the problem description, and that gives you some kind of a responsibility. So here we have like adding and removing, and that give you a responsibility of something. Then, as we've just gone through this exercise, you still have to figure out who is responsible. And so that is probably the hardest part of them all. So let's say that you know that someone needs to add a message to a mailbox, and then you still need to figure out who is it. Let's see if I have a pen. So when you think about it in Java, it's easier to see it in Java. You kind of want to ask yourself the question, which way is the program later going to look like? Is it going to say message.add to, and then the mailbox as a parameter, or is it more likely to be inbox.add and then the message? We don't have to program yet, of course. It's our goal to get to the program, but still, you know how to program in Java, and so you can kind of guess which of these is the more likely thing that's going to happen. And so it's more likely that when you have something that collects things, that one adds to the collection. And you can know that because you've already seen a whole bunch of collections, like array list or linked list or something, and it's never been like string adds itself to an array list. It would be weird. And it would really only work if the array list then later also knows how to add a string to it, so you might as well do that the right way. So you always have to find this one responsible agent. And when you look at the syntax for an object-oriented method call, you see that agent is really special, right? That's the one that's before the dot. And here I don't mean agent in the restricted form as before. So it's the one responsible object. I say it like that. The responsible object is before the dot, then you have the name of the method which implements the responsibility, and then you have 0 or more parameters. And so we always want to look for this one guy, and then we want to say, oh, this must be a responsibility of, in this case, the mailbox class. And then we can go back here and say, what was it? Mailbox. Never mind, we don't go back. All right, so we're not going to talk about class relationships. We skip past these because I want to talk about CRC cards quickly. So there's this kind of informal technique that was developed 20-some years ago when objects were all the rage. And people were genuinely challenged in coming up with classes for new projects. Programmers had grown up with different techniques with identifying functions, and they just really were at a loss as to how to do this. And so these two people, Cunningham and Beck, came up with a very simple technique for doing that, and it really does work pretty well. You take a paper index card. Nowadays, no one has them anymore. I had to go to the archive and get them. But 20 years ago, people actually used paper index cards. And so then the idea is you write the name of the class on the top of the card, and then on the left, you write the responsibilities. And now these responsibilities, that's also a challenge for people to write them up. You kind of want to leave them at a reasonably high level. That's a lot easier if you have a lot of experience designing these things. So give it a try, but it's quite likely for beginners that they will look very much like methods. What's the difference between a responsibility and a method? You can have a responsibility that needs more than one method to execute. So a responsibility is at a high level. For example, manage new and saved messages. There must be 3 or 4 methods that are involved to do this managing. And as a beginner, there's nothing wrong with writing a responsibility, add a message, save a message, delete a message. That's fine. But then you can think about it and say, well, really all I care is that it manages these messages. Yes?
So we basically should keep it broad.
It's a good idea to keep it kind of broad, but it's one of those things. If it's too amorphous, and just say, do whatever is required for the project, right? Then that's not helpful. So somewhere between do what's required for the project and a minute list of everything in gruesome detail. You want to be somewhere in between. And the only way to get there is by just kind of not doing it very well the first few times. Yeah?
Why wouldn't you want it more, why would you want it broad?
Because a very good question. When these systems get complex, if you have too much detail early on, it's very confusing to manage. That then you spend a lot of time on the finer grained details and you don't see the big picture. That's true generally in life. That at this point here we want to be strategic. So that I always say, when should you be in strategic mode and when should you be in tactical or implementation mode? So at this point, we want to see the big picture, want to understand what the key classes are and what they do so that we can have some idea what's the effort required and how can we distribute the teams so that some teams work on this cluster, some teams work on that cluster, and so on. And then we'll leave it to the experts there to go into further detail and figure out the finer meanings. But I realize it's difficult for students who just came from a couple of classes where you were the implementors and you did have to figure out every last detail, and it'll come natural to you to do that at this point. And I would say don't sweat on it too much. Just do something. The hardest thing is to do something. The hardest thing is to have that transition from the empty index card to the index card with something written on it. That is really hard. Afterwards, it gets easier, and you'll gain experience with it. I just tell you what the ideal state is to have people who can give you the strategic goals so that they neatly map into the implementation. Sometimes that doesn't happen. I've had more than one design that I said, oh, this will work great. And then when one tried to go down that path, it turns out that something important was overlooked because there wasn't that level of detail there. But more often than not, people who have some experience can do this just fine. So that's the thing. So, and Cunningham and Beck were relentless about this. They said 1 to 3 responsibilities per card. They would go through their training courses, and when someone had a card with 20 responsibilities, they would take it, they would rip it up into shreds, and they would say, try it again. Just like once I was working in a startup, and my boss, whenever I gave a presentation, and there were more than 40 words a slide, he would erase the slide out of the deck and say, start over. So, same idea, that at this level, one wants to be high level if one can. So, the next thing is collaborators. So, one of the things that one wants to understand is when when a responsibility is taken on, which help does this class need? So here the mailbox, in order to manage the messages, it needs actually two message queues, one for the new and one for the saved messages. And so one records that and say, this card needs to collaborate with that card. This class needs to collaborate with that class. And that's still kind of broad. We don't know how many of these there are or where they are. We just know that in order to do this part, the mailbox needs to talk to a message queue and say, hey, you do something else. When I write it like this, it doesn't mean that the message queue is responsible for this particular operation. They're not, the left and the right are completely independent of each other. I just make a random list of the collaborators that I find. And what's most interesting to me is what collaborators I don't find. So over here, if I don't find that the message itself is a collaborator, then that means the mailbox never looks inside the messages. It never calls a Java method on a message. And that's useful information. That way, the mailbox doesn't seem to have to know much about the message class, and they can evolve separately. All right, so now I'm not going to do this in great detail, but what people do when they have these CRC cards is they sit on a desk and then they kind of play scenarios through. And so they will actually, typically, someone will grab the card that currently is responsible for doing the first thing. And it gives a tangible feeling for what that was. So here, we have this use case for leaving a message. So the caller connects to the voicemail system. At this point, someone might say, well, that must be the system class. And let's see if the system class has some responsibility that deals with connecting or some such thing. And then the caller dials the extension number. Well, who processes that thing? Is there a class like an input reader or some such thing? And in that case, if there isn't such a card, then you start asking, well, what's actually happening? Someone must be calling scanner.read at this point. What is scanner.next at this point? Well, who the heck is that? And if there's no class for that at all, no card for it, then you say, well, I guess we do need to have some kind of a card for that. In the actual implementation, I call that thing a connection. I made up a concept for something that has to deal with all of that input and output thing, and I call it a connection. And then one needs to locate a mailbox to put the message in. Well, how the heck are you going to find that mailbox? There's many of them. Who stores all the mailboxes? And that's when I came up with this mail system. So if you know nothing, you can simply grab onto any old scenario and start playing it through, and that gives you a wealth of classes and responsibilities. It's a good way to get started. And then you can go through the 4 or 5 or 6 key scenarios that, for a small project, make up the bulk of the complexity. And you get a pretty good stab at what is in a small system like that. If it's a huge system, then of course you're going to have to go through many more. But oftentimes a large system comes out from a small system. So this is not a bad strategy. Now, do people really do this? So I talk to people whether nowadays, after 20-some years, it's not as common as it used to. So I wouldn't, on an interview, say, I love CRC cards, because the interviewer might say, you love what? But it's not a bad thing for someone who's a complete beginner. And that's how the inventors envisioned it at the time. At 20-some years ago, everyone was a complete beginner in object-oriented programming because it had just been invented. And so they said, this is a very good way of breaking the ice. So we'll actually do this today, and we might do it one more time. And after a while, hopefully everyone is expert enough that you don't need this particular thing. But it is a nice way for getting going. What we learned on Wednesday, the UML diagrams, they're much more common, and so those you don't have to be embarrassed to mention in an interview. All right. So with that, we're going to get into the lab. And so what I want you to do in this lab is to spend a few minutes being an object-oriented designer at this early stage. And so this time we're going to be having a scribe who answers some questions, and the coder doesn't actually code. You're just going to do lists on a sheet of paper and a CRC card or two on index cards that I'm going to give you. And so what I want you to do is that the scribe writes down in text as before, and that the quote-unquote coder is the one who fills out a sheet of paper with a list of classes maybe and a couple of the index cards. So you get a feel for how that goes. And then just take a photo of it and upload that. All right, so let's get going. So, we're just going to be simulating Piazza here. You know Piazza, and so imagine that you want to write a Piazza simulation that kind of works like the voicemail simulation, text-based, boring, not very attractive, but that has the basic features of Piazza in there. And so just work with your buddy and say, what classes do you need? What would be reasonable classes? And think of a couple of scenarios, not too many, but 2 or 3. And then work through one of the scenarios with the CRC cards. And then I want to see later what cards did you come up with. So if your buddy from last time isn't here, just pick a new one. If there's an odd number of people.
I wonder if you want to take a look.
I think I forgot to
I'm just downloading everything.
So we have to have part of this is the same thing. Well, I'm sorry. Make it direct. You don't include basic attributes, right?
No.
They might be later.
Yeah,
but
maybe
these are the simple
For now,
Okay, sure.
I'll go ahead and write it down.
So then is that called a positive? Can you have like it's like a database will be courses. 5, 8, 9. And now courses, course 5 will say user 1 will say we need courses never gets to say user 5
Yeah. would that be? I guess class. Yeah. Class.
Okay. Can I have a couple of minutes so that we synchronize on the first step? So the first step was to find some classes. So just shout some classes at me. User, okay. Course. Host. Okay.
Login event.
What's that? A logging event?
Login event. Okay.
What is it for?
It triggers. It allows you to log in and grab all the items.
Oh, login event. Okay. I'll put it. And then, okay. What else? Statistics. You say, okay. Yeah. Well, I'm just writing down right now. We'll eliminate it later. Yeah. Post. We have post. Poll. Okay. Yeah. Okay. A post list. Okay.
Maybe like form and aggregate.
Okay. Is a course and a forum the same thing?
Well, the thing that holds courses,
Can
like the whole system, kind of the mailbox system.
Oh, I see. Okay, so I'll just write the whole. So that's just right system then. There's no right or wrong answer yet. I'm just collecting.
Were we doing this about the entire Piazza system?
Well, that question came up, right? And those of you who can model all of Piazza in 15 minutes, that's great, right? What I had in mind is that the core of Piazza, which is you ask a question, someone gives an answer, that kind of stuff. Okay, so if you look at how Piazza is normally used, and maybe we haven't used it very much like that yet. Come on, Piazza. So like the normal way is not for clicker questions, but is someone said permission to clone denied, right? That is a typical Piazza question, right? Someone has grief, unconsolable grief, and so they put a question, right? And then what do we have here? We have a student answer. We have an instructor answer. Right, so now this would be a really good time to look at our list here.
Answer.
Aha, okay. So then we have an answer, right? And then there's this thing, how Piazza does this thing here with this follow-up discussion thing. And so this is the way how Piazza chooses to do this, but you guys used it, right? Here, there's a discussion. Someone had a discussion with themselves. Someone, here I said something. Someone said something. So we might as well use the terminology here and say discussion. Right, and then with a discussion, this is, I guess, would be a comment, and then I guess you can put a comment to a comment. Can you put a comment to a comment to a comment? Okay, so maybe one wants to call this thing here a comment and this thing a response or some such thing.
You comment and comment response?
No, that's what I was asking. Can you comment a comment?
Well, I mean the name of it, like have a comment. The name of the class would be comment and then comment response.
Okay, sure. Sure, yeah. So this is kind of a set of classes that you might come up with. And so what I would do at this point, I would say, the system, I don't know, I'll leave that till later. The login event, to me, is too fine-grained. That's the login part, I have to eventually worry about that. And the statistics, others were uncomfortable saying, what the heck does the statistics do? I would keep that aside and say, maybe I need it at some point. And the poll, I would say, don't dwell on it today because we just don't have enough time. But this gives you some good idea. You may already have classes that were similar to these, and then you can just keep the ones that you had. Or if these give you new ideas, then that's great. All right, next really quick question before going on to phase 2. I said look at some scenarios. Give me just a couple of interesting scenarios that we want to look at. Yeah. What? Let's not deal with the clicker polls today. Let's just focus on Piazza, how it's intended to be. The clicker polls are kind of something that was grafted onto the system, but the original thing for Piazza was, someone has intense grief that they can't figure something out and they need help. So give me another. Okay. Yes, that's fine. So here you have like 3 key scenarios. Get going with one of them and see which classes that you have are responsible for which parts. And that should be an interesting discussion. Don't focus so much on the login part. That is an essential part of every system, but it's not usually super interesting. All right.
Essentially,
That's all. Yeah, their own class. I guess yeah. Question class. And what will it do? Add mainly for the utility.
Oh, we just did describe it. And right now, how do you I mean, there's also like,
Well, I just wanted to share a couple of parts.
Dependency would be,
They all have All right. If I could please have a few minutes so we can go through some of this thing together. So let's say that I have the scenario where it says respond to question, right? And so some user, and it presumably has seen a question, and now they want to respond to it. And so let's quickly look at it, how this would look like here. So here we have something where now we see this thing. How do you respond to this? You just fill in something in where it says the student. I can't do this, right? So what do you get at this point? You just get a text field here, right? So now when you get a text field, you are not the object in the system. So there must be some object in the system that gets called when you click on what button do you click? There's some button in the end where you say post, right? So now the post button gets clicked. What happens then? That means that the web browser actually sends the text and a command to someone, and so then there is this part that's hard for us to model right now because we don't really understand the web technology. That says, okay, now I have. What do I have? Presumably that the information contains the ID of the question that's being responded to, and the response, and the response text, and I guess the ID of the person who is doing the responding. So which object then processes that? Yeah. Does the answer process it? So what I'm saying is that at this point here we have as data, we have the question ID, we have the actual response text, and we have the respondent user ID. That's what typically happens in a web application. These IDs get sent up to the server. There's some piece now in the server that says, okay, now I need to spring into action. The command that I need to do is respond to question, and this is the information that I have. Now, what are they going to do? They're going that piece of the system is going to have to get a hold of some object now. And what is that object? And so one of you said it's the answer. But I don't buy that. The answer needs to be created. There is no answer yet. There's no answer object yet. All we have is a bunch of strings. So yes, an answer object does get created, but creation is kind of not something that every object has a constructor and has to be creatable. Now that we have an answer, what do we do with it? Normally, the way these things work, I understand where you're coming from. So in a web application, what you first do is you update the internal data structure, and then afterwards you worry about displaying it.
Well, the thing, I don't know, I sort of approach this from the perspective that, like, the question would be there and the answer would be there too on the creation of the question. It just already exists, but it just wouldn't have anything in it.
Okay. So fine, there's no, but if you create the answer, you might as well create the answer with the text that we have. But whatever, so we have now the answer object. However, we have obtained one. What do we do with the answer object? How do we find the question? So See, what gets sent to the web server is not the question, but the ID of the question. Because there might, after all, be more than one question with the same title. Right? In every beginning course, there's multiple instances of a question with the title. I have no idea where to start. But each of them has a different ID. So someone needs to be able to look up those IDs. So how would you, given that you have question ID number 35, how can you find the question object? So I would put them in some kind of a list, like a container or something. Unfortunately, I erased my... Does anyone have a class for a list of questions, or what did you call it? What's that? Post list. Okay, so in his situation, he has a post list class. And then the post list presumably says manage posts or something like that. Yeah. And so then one could ask the post list instance, say, hey, I have post ID number 42. Give me the, I guess he would have called it a post that refers to. And then what might that post have as a responsibility? Or question, or whatever you might have called it. Well, now I have an answer. What could I do with the answer? What's that?
You submit an answer.
Well, me is there's the user, and then there is the program that. So we're past the carbon life form that has done the submission. We're at the server level. The server has at this point the ID of the post, I guess, of the question, with the text of the response as a string, and the ID of the carbon life form that did all this. Now the server, that part of the server that we haven't given a name that processes the response, has gotten a hold of the post list that, thanks to them, the post list says, hey, here's the actual post, an object. What can I now do with that post? Yes? I could display it. The displaying, let's not get into the display right now. I want to update the data structure first before displaying anything.
So the post contains like its own answers?
Presumably, the post contains an answer, right?
Yeah, so you would update with the answer.
I could have a responsibility here that says add answer. Right? And at this point, then the answer would presumably be swallowed up by the post. And then what you say you want to display it, there seems to be the urge to display it, so I'll just say the thing should be able to display it, meaning that it should be able to produce the HTML that's necessary to render it, or some such thing. Okay? So that's kind of how one goes about these flows, and we've done well. We've found a new class here that we had not seen before. And that class really is necessary. There needs to be someone who manages this list of posts. Yeah?
We can have post lists just be a part of a higher class.
You could. There could be like a system class. You can always stuff everything into a system class. And so the question is, when is that wise, and when do you want to have something at a lower level? And you could go either way on that. Okay, so I hope that's given you a bit of a flavor on how this process works. And you know now that you can't do it in 15 minutes. Take a photo of your cards and put them into Piazza. Not into Piazza, into Git, so that I can have a look at them and see if I want to talk about them more. Thank you.